I'm very pleased to welcome Sean Lally to Waterloo as our lecturer this evening. Sean is the principal and founder of Weathers, a firm whose approach to energy moves beyond the framework of conservation and efficiency and the rhetoric of sustainability to imagine what it might mean to design with energy, heat, and atmospheric conditions, much in the way that one might design with concrete and glass and other traditional building materials. Sean asks us to envisage architecture not only as a physical extension of the geological crust of the Earth's surface, but also as the bottom layer of an ocean of air, and to invest the same degree of design intelligence and invention into the organization of the thermodynamic, acoustic, and electromagnetic milieus. His propositions in many ways transform the way that we think about design within architecture. Sean's office has developed a number of different projects, including proposals for the Gdansk Museum of World War II, the Stockholm City Library extension, and the urban redevelopment proposal for Reykjavik, Iceland. He's also a co-editor and contributor to Soft Space, from a representation of form to a simulation of space, and was a guest editor of AD for the publication Energy's New Material Boundaries. He's also just completed his recent book, The Air from Other Planets, A Brief History of Architecture to Come, which he'll be lecturing on this evening. Sean is also the recipient of many awards and honors, including the Rome Prize from the American Academy in Rome, and the winner of the 2012 Architectural League Prize for Young Architects and Designers. He's a graduate of UCLA, and he's taught at Rice University, and he is now an assistant professor of the University of Illinois at Chicago. Please join me in welcoming Sean Lally.
Hello. Thanks for that introduction, and it's great to be here, so thank you for the invitation. So I did switch it up a little bit in the sense that I think I submitted a lecture title called The Air from Other Planets, but I do tend to get a bit restless, so somehow still talking about that title caused me to shift my attention to a new title for today, which is Ride the Lightning. And to give you an idea of where this comes from, I was a couple of years ago searching through a couple of things, and I ran across this Urban Dictionary entry, entry number 6 by Luca Rockbin from October 8th, which says, 1, Ride the Lightning is 1, American thrash metal band Metallica's second album, released July 30th, 1984. Quote, Ride the Lightning is the best album ever, which, for those of you who aren't familiar with it, is essentially a true statement. And to be honest, that's where I got the title from. I was listening to that album. And then number 2, Ride the Lightning is an execution method of an electric chair. Scott is on death row. He'll be riding the lightning tomorrow. 3, using an electric guitar or any other instrument which has its sound amplified by an electrical method. So to paraphrase this, what's with that crap? That's unplugged crap. How about you plug into the amp and ride the fucking lightning? And so it just had me thinking about, believe it or not, this had me thinking about architecture. And just the sense that you could say that architecture in a way is doing that now, in the sense that as electricity has been brought into the interior of buildings, that we've electrified the interiors, and that these buildings could be the acoustic guitar that has then been electrified. But what I would really say is, and this is a working addendum, but essentially that Riding the Lightning is a physical space that is built and occupiable because of an amplification and design of the energies that course around it. So not thinking of architecture, say, as kind of ossified energy, meaning kind of the brick and mortar we think about in regards to architecture, but actually working with the energies that we have around us at all parts in time, which I'm going to talk about a little bit more, that actually become the architecture itself. So, with that in mind, obviously, you can see that a huge portion of my interest, based on the office's name, the title of the book, is that my interest lies heavily on thinking about what are other kind of materials out there and how they affect the human body and how they affect how we build space. So this is not my work, but this is a great project that is an installation that has the dimensions of a private house. It has the dimensions of an entry foyer. You know, it has the living room probably. This is where their stairs would be, or living room, kitchen. It even has the doors cut out for the passageways. But what it kind of stands for, which I thought was really intriguing, was that you can define architecture a lot of ways, and a lot of people have different ways of talking about it and describing it. But for me, the way I think about it and the way I approach it is to say that for architecture to exist, you have to have a physical boundary, something that actually is a physical condition that the body can perceive and make judgments upon. So if that's the case, then you're talking about a material that can organize space, has social implications in terms of organization and structure. It has aesthetic value, meaning you can approach it and judge it based on some aesthetic qualities, and has the organizational implications tied to it. So this is a residential house, but of course it doesn't have brick and mortar. It just has the grass. So obviously you can move. Ironically, looking at the image, you can see that actually no one is actually walking through the walls. They're actually walking through it and using it as if that was an interior space. But those things then play a role in how we think about space and how we define space. And for the most part, when we think about this, there's a couple of things going on. Two of the biggest pressures that are outside of architecture, that are basically in the realm of architecture itself, are an annual industry of roughly $7 trillion a year, which is the energy industry, whether you tie that to fossil fuels or renewable energy, and bioengineering. So on one side you have energy, which is, for the most part, if you start thinking about it as an architect, you think, how can we actually use this as a building material? Isla mentioned at the beginning the idea that, can we think of architecture and energy as a new material, the same way we think about glass, steel, concrete. These things didn't recreate something we had before. We don't have a better hut that's no longer in a thatched roof, but is now in brick that then went into steel and then went into glass. Each time we worked with these materials, there were social pressures upon them, along with the material itself, that gave us new typologies, new things, new types of architecture, and new ways of living. And so my interest is to think maybe energy should be that. Maybe we should be thinking about energy like that. The second one is bioengineering. So basically working the human body and designing and tweaking the human body in new ways. And I'll talk about that in more detail, but essentially trying to think, how does the human body perceive these spaces, perceive these energies, and allow them to actually become architectural shapes and spaces. And what's interesting about this is that if one is about as a materiality, and one is about redefinition of the human body, which we all are designing for, architects are kind of right in the middle there. We're in the position to actually take these two industries, which for the most part don't correlate with each other and don't cross over, and for the architect to come in and actually think about how these huge forces that are affecting us, not just as architects, but as a general society, and actually can reinform us as an industry. But when we think about this, generally speaking, within architecture, energy for the most part is seen, and for many very good reasons, as an low energy, high efficiency modeling system. Meaning it's really all about conservation and preservation. So it's about preserving the environment we have around us today through conservation, meaning holding on to it, and bringing down our use of energy because it's tied to so many other things and other political conditions. But there was a great article that I read called Innovation Starvation by Neil Stephenson. I don't know if any of you know him. He's a fiction writer. He wrote Snow Crash in the mid-90s, has done Quicksilver, the Baroque Cycles, somewhere between science fiction and just general great fiction. And he was at a conference down at Arizona State University. And this article that he wrote called Innovation Starvation is really about this interaction that he had, which is to say, on a panel with a bunch of people, scientists and engineers from Arizona, talking about the projections of where we are going as a society. And in a kind of crabby way, he's lamenting the fact that as he grew up, the Apollo missions, moon landings. This is actually also the same year in which the space shuttle, the way that this conversation is happening is the same year the space shuttle is being decommissioned. So he's talking about how these things that he's been promised just didn't materialize. That somehow these hopes and these desires that were kind of brought through the 60s and the 70s didn't make their way into the general population. And that really, he living in Seattle, the biggest thing that he's dealing with is the fact that it's taken 3 years to figure out whether or not they're going to put bike lanes in the city. And so he's kind of talking about these as these kind of big problems and where this is going and why this is playing itself out. And to his great surprise, he has in the audience, well, he's not surprised about who's in the audience, it's Michael Crow, who's the president of Arizona State. But the reply he gets, which is essentially to say, and I mention this because I think you can tie this discussion of science fiction to The Architect in a little bit of some ways. One is I think that generally speaking, The Architect is a great, Bob Somel says, a director at UIC, that it's one of the last liberal art education humanities, in the sense that you do get a little bit of everything, but you're not really a specialist in anything. And quite often when the architect talks to other professionals, there is this insecurity that somehow you don't know as much as the other people in the room, because of course you're kind of carrying a large umbrella. You're not the specialist in any one field. And so while he's talking to these people, these scientists, he has this recollection and a kind of very similar approach. But what he gets back from Michael Crow is a statement that says, you know what, it's not us as scientists and engineers that have failed, it's you as science fiction writers. That all you provide are dystopic or utopic worlds, and you don't create the kind of projected possibilities out there that get people excited and inspire a new generation to want to go into the sciences. And so this kind of takes him back to realize that his role as a fiction writer is actually quite strong, in the sense that he can actually do something that actually plays in the role of science and engineering that isn't simply about pure speculation, but actually realizes that it's in a larger kind of database of conversation. But one of the other things he points to, and so this comes to this kind of conversation about, this is CERN. Kind of, you can't get a bad picture of it, to be honest. But it's this conversation of what are we doing when we think about some of the biggest crises that we have going on around us, whether it's the idea of energy or the idea that the kind of bioethics and moral implications of engineering the human body. In architecture, we generally kind of are pulling back, in the sense that we do have the responsibility, obviously, of our clients and of a society to work with clean energy and bring buildings in and not waste energy. But at the same time, what we're not doing enough of, in my opinion, and the work that I'm trying to work on, is to try to figure out how can we actually give the general public and people beyond us a kind of inspiration of what we could do should we have more energy, should we have more ability, more resources, more clean energy. How is the environment around us is never going to be conserved. The environment that you woke up to and the environment you go to bed at tonight will be two different things. So it's always on a course of movement and change. The question is, can we think about and plan for that in the future, realizing that it won't be the same? It'll be different, but maybe somehow responsible and sustainable in a very different way. And to do that, maybe we need to start speculating more about what the possibilities of energy can be, how it can be used, how we can give it shape, how it can be a material to spark these conversations and have these debates and conversations. And so we're looking at the CERN and the Large Collider here. Basically because if you just read, I know it's kind of small, CERN has 1.3 terawatt hours of electricity annually. That's enough to fuel 300,000 homes for a year in the United Kingdom. At peak consumption, usually from May to mid-December, CERN uses about 200 megawatts of power, which is about 1/3 of the amount of energy that the nearby city of Geneva is using. Right? So it's an astronomical amount of energy that is allowing for scientific discovery, new knowledge, so on and so forth. So there are plenty of examples in which sometimes an excess of energy can actually get us a greater understanding of where we are and where we're going. The other kind of subtext that happened within this conversation he was having was that within engineering and in the sciences, breakthroughs and research that are happening, say whether it's in the cancers or whether it's in the pharmaceutical business, require decades of work and discipline. So when you're going if you're going into chemistry or you're going into these engineering fields and you go to get your PhD, the kind of research and specificity that you're doing is very tight. it could very well mean that when you do go into your first job afterwards, that you're working on a very particular and a very small segment of a very large problem. So there becomes a specialization that's kind of inborn within the pursuit of innovation. And again, what becomes interesting is when you look back at the architect as a profession, it gets the realization that because we are not, to speak, we're not really specialists in anything. We have a large database of knowledge, but it's really a kind of larger umbrella move. And when you start looking at, so this is an approach of the architectural profession from, say, the idea of the 15th century of the architects. Think about Brunelleschi doing the Duomo in Florence, right? So architect, engineer, construction, creating the devices, inventor for the devices that would get the material up there, to the idea of the engineering for the metallic chain that would hold the thing in tension, blah, blah, blah. And so there was no schism really until, think about the 18th century, where engineer and architect kind of break apart the Beaux-Arts education, the advent of iron and steel, where this kind of knowledge base goes. But if you look on the far right, what I'm looking at here are, in white, are governing bodies for profession. So the architect, American Institute of Architects, 1857 is when it was formed. Landscape architect, 1899. American Planning Association, 1978. So some of these are only or less than 40 years old. Structural engineer, mechanical engineer, civil engineer, acoustic engineer. And in the United States, interior designing. I think there are 4 states that require licensure in the United States for interior design. And here on the bottom here, these are not professional organizations in terms of licensure and education, but everything from photovoltaic plant to wind studies, team building, you can go on and on. So in order to produce a project like this, you start to see, so if you pull up a project, and I'm sure in your studies you've run across Köppen and Blau's BMW project, this is nothing but the credit list to produce this, right? So you're looking at everything from lighting consultants to facade consultants to landscapes to kitchen technologies, signage, inspection engineer, team building. The requirement to do these projects sometimes requires a role that the architect would take on in terms of the team organization is now being done by someone who does nothing but team organization, making sure everyone gets along and gets the project done based on representing the client themselves. So when we start thinking like this, you realize that sometimes, and this isn't, what do you think we would call it? Like a rationalization for what I'm about to show you, but it is a logic for why I'm trying to approach this the way I am, which is to kind of take a step back and have a kind of a broader discussion here, which is to say, generally speaking, when we think about architecture, we think of it as an act of mediation for good reason, right? So architecture is this pink line. So this, if you read anything, Well-Tempered Environment by Rainer Banham, he talks about this as whether or not we're talking about selecting materials that move through, think a door, a portico, a porch, to the ideas of things that bounce back, to the ideas of things that are absorbed. So like thermal lag, or the idea of interior, basically sealing the whole thing off with air conditioning and heating. And so the question is to think, why can we not start thinking of architecture not as the kind of act of mediating the environment around us, but actually manipulating the environment itself to become a form of architecture, to actually an architecture in which you amplify the energy systems that exist around us to become and form the architecture. They have the aesthetic, they have the organizational, and it's just a separate way of thinking about architecture, not as a shell, but instead as basically an intense microclimate itself. And so, when we do have these thoughts, you're thinking about every time this discussion of material, whether it's something from Richard Neutra's glass and spider leg, Southern California, pool that moves from the inside to the outside, borrowed landscape, obviously thermally and geometrically, that is a space, it's a glass wall, or the curvature of TWA, or steel, the idea of the spanning mechanisms and such that you get from this. So when we think about these moments, each of these things didn't reproduce something we already knew. They actually allowed us to come up with new possibilities. A kind of perfect example of this would be say, the great exhibition halls of Paris and London, right at the turn of the century, where you have the Industrial Revolution, you have a colonization of these large nations that are going around the world, bringing these things back, everything from plants and animals from around the world, from their colonies. You have a kind of interiority of the kind of national identity. You have the Industrial Revolution. You have this kind of pride in which they're trying to show these things off. And what you start to get is both an advent of iron and glass that come about to create these great exhibition halls that give us the greenhouses, that give us building types and spans and interiors in terms of mass production, but also in terms of shapes and sizes that we didn't have prior to that. It's not simply the architect stating that I have access to a material and I will be a great creator and create something new. It's actually the social pressures upon it that are allowing that thing to happen. So it's not one or the other, it's a combination. And so if you think today, when you talk about energy, you realize that the great pressure is the fact that this affects everybody worldwide. It's a global issue, it's a global crisis, in the sense that this is something we need to be thinking about, and maybe the answer isn't always to conserve and become efficient and low energy, but maybe it's actually exploring and start to get this out as a kind of different conversation in and about the world around us. And so with that in mind, to kind of give an example of what I'm talking about, I think street lighting is a kind of great example of what I'm talking about when I think about an architecture made nothing else but really a form of energy, which is the visible spectrum of light. So when you have street lighting, you have an individual object here that produces a spectrum of light that the human eye can see. It doesn't duplicate the sun. The intention in creating an outdoor lighting is not to produce the sun and all the energy that comes from it in terms of the radiation and spectrum. It's simply to produce an inhabitable space. And when you look at street lighting, for me, this is a form of architecture. It has the criteria that I mentioned a moment ago, in the sense that it has a physical boundary. When you're in it, you have an interior. When you're out of it, you're on the perimeter. The human body can perceive that boundary. From a distance, it gives us safety. When you're in it, you have that safety. When you're out of it, you don't. It allows activities to happen at night in parks and in plazas that couldn't otherwise exist in terms of recreation and commerce. And it has an aesthetic shape. It has a visual identity that you can tie to. When they're separated apart, it's a sort of archipelago or a pearl necklace of separate shapes. When they're tied together and they're multiplied thousands of times, you get the kind of great washes, and when they're misused, they become the light pollution of cities. Cities like Chicago that are, in a sense, actually removing light from large portions of the city because of a light pollution condition. So it actually does not only work as an individual object, but it actually works as a much larger field. And this is just with the spectrum of the visible light. And I'm not going into it in too much detail, but when we talk about these energies and how they become actual materials, just referring to them as a material energy, like an actual thing that you can build with and construct with. And we're familiar with them in our daily lives all the time. So if you are familiar with Jeff Kipnis's article on the cosmetic, he's talking about Herzog and Demeron, and as well as many others, and he's talking about them as effects, moods, qualities, things that are kind of laid on top. And there's no shortage of those in architecture, right? So we think of energy, whether it's generally in the cause of an aura, it's something that is a kind of byproduct. It's not an architectural material. It's just a nice effect or quality or atmosphere or mood that requires the wall to be there to do it, right? So without that wall, that effect or that mood or that quality would disappear, but the energy kind of lays against it in a kind of lazy manner, and it gives us these effects. But it's really not organizational. The geometry, the wall around it is doing all the heavy work. The other one would be to say comfort control. So we know in the last 50 years, probably since the last 40 years from the time of the great energy crisis in the 70s to NASA, that we can quantify and represent energy through simulations. We have the ideas of interior comfort control with our heating and mechanical systems, the idea of an ideal temperature, an ideal relative humidity that basically all interiors cover. But again, the walls, the geometries around us are creating this space. We just fill it like an air in a tire, right? So you have a tire, you run the air in it, gives it its shape, but really it's the tire, or it's the building that's doing all the organizational work. But when we get into these material energies, whether we're talking about electromagnetic, whether we're talking about thermodynamics, whether we're talking about chemical or acoustics, we have these three rings that are known. These aren't things that I've come up with. These are things that are thought about within environmental sciences, and how animals and animals and humans interact with space around us. It's generally done in three ways that you identify information in your environment that you make judgment calls on. So the first one would be trophic, which just to say it gives you nourishment to the body, right? So when you get sunlight, it's giving you vitamin D. It's doing things to your body that will make you healthy. It's long winter months. You don't have that access to it. People go into depression. People's moods changes. This has a lot to do with basically energy that is affecting the human body's physical wellness. The second is informational. So that's what street lighting is. And informational means that you get a shape here. It's light. It's producing a form. It's producing a shape. I have some degree of access here. You can see me. I can't see you. Again, as we talked about, it gives opportunities outside in the environment around us. But I can disregard it. It's completely informational, meaning my body can move through it. It can pass it. It can determine whether or not it wants to acknowledge it. But it has its ability to at least sense it. And the third would be physical. So we're all familiar with physical in architecture because we think about it in terms of walls, meaning I can't run through this. I have to go up these stairs. It's a physical condition. But energy is used like this as well. There's no shortage of examples within, generally speaking, it's usually the military. Everything from sound cannons, lighting, lasers, anything that can cause a physical boundary that your body wouldn't pass through until it causes actual physical harm to the human body. And so these are, when we think about shape and we think about these energies, they don't fall within a clear dichotomy of mass or void. When you think about architecture, people talk about space and form or mass and void. Obviously, it's a lot more of a kind of in-between stasis within here. The other part of this conversation is one of the human body, which I touched on kind of quickly. And the human body, for the most part, has had a huge, long history of kind of understanding the shape of the human body, and not just the shape and proportions, but how the body works, right? So when you're looking at the Vitruvian Man from Leonardo da Vinci, we're looking at a period of time in which a large jump in knowledge of the human body has occurred. So this is somebody who's dissecting cadavers, which is illegal at the time, to try to understand how the skeletal system works, how tendons connect to the muscle, and try to figure out how these things are all coming together. And in doing so, he's going back to Vitruvius and trying to figure out his idea of proportion and locking these all together. But there's a kind of weird collusion happening here in the sense that this is all about the outer surface of the skin, right? Proportion of finger to body to waist to leg to head. And these are all really about the outer skin of the human body, which then gets translated to the outer skin of a building in terms of proportion, what beauty is, so on and so forth. And these are all for very good reasons, right? We have heights for doors. We have treads in terms of how the body moves through it. We have a definition of how high a chair should be so it's accessible and it's easy to sit in. These forms of ergonomics are essential. But it's also not a coincidence that when we think about proportion and skin, we are making a proportion that goes directly to then the skin of buildings, whether that be fabric or concrete or steel. And this is just a great little piece from the New Yorker. It says, it's on evolution. I was wondering when you'd noticed that there are a lot more steps. Basically just talking about the evolution of the human, in the sense that we'd like to think of ourselves as the kind of pinnacle condition. Everything before us was previous, and then we maintain ourselves going forward. People have different conversations about whether or not anything natural is currently occurring or jumping right now. For the sake of argument, let's say no. But it doesn't mean that we're not engineering our bodies day to day, right? So up to this point, really so much of our knowledge about the human body has been about learning about the body so that we can know more about it and how it works based on how we then work with space around us. But the fact is now the human body itself can be and is being engineered, right? Everything from the fact that you've probably all been vaccinated. We've all been to the eye doctor. We've had our hearing checked. If you're on antidepressants or anything for the central nervous system in terms of behavior, these things are all being engineered in terms of the human body, and these all course through us day to day. within our generation, it's thought that, and it's true, I guess, is that when you go to the doctor now, so much of how we think about and we treat the body as a society in general is to go back to an idea of average. So there's a definition of what average is. From the day your child is born and they weigh it and they count it, fingers, there's an average condition, and you're either above it or below it. And when you're born, your hearing is tested, your eyes are tested. These are things that we think about, and we have an average condition that then technology has been done over and over to then bring us back to a state of average. So you wear glasses. You want to know when you wear glasses? You can wear contacts. Now through contacts, we can actually do LASIK surgery. And now if you're going into the military, it's possible for doctors to actually have to decide to hold back, in the sense that they can actually give you better than 20/20 vision. So within our lifetime, whether you're dealing with so-called a below average condition that then needs to be corrected, you're no longer talking about doctors who are trying to find something to bring you back to a state of average. You're actually talking about people who are going to have to stop in terms of their acts so that they don't go beyond the kind of average condition. So the body is continually being worked with and essentially designed. So this is not, and this is what I'll get into in a minute, is that this is not universal. This doesn't happen in all parts. This doesn't happen with all people. There are a lot of moral and ethical questions that are tied to this. But if you think about the human body, our knowledge about it, whether it's the idea of the circulatory system or optics, everything from the Greeks understanding the entis, how our eye is kind of a weak form to it, and therefore you bow out the columns and you ramp up the distance of a temple so that from the distance the human eye will correct for that and see it as a flat shape. To genetic sequencing. So your grandparents didn't know what DNA was when they were younger, and now we're sequencing the entire genome of the human. And now each of these things has allowed us to then understand the human body differently in terms of the materials we use, whether it's trying to figure out how we're going to encapsulate that body when we send it into space, or put it in deep exploration, or understand how it's going to, the theory of how the body deals with certain colors, colors in prison, how colors work with students in teaching. But they're both separately have been thought of as separate trajectories. One, which is a knowledge that then allows us to re-inform and think about it. But if both the human body and the materials we're working with, energies and our human perception, are both on the table, that means both are kind of feeding in a feedback mechanism, a kind of arms race in which one can give the other a different information and allow the two to kind of work back and forth. So both are at play in terms of design in many ways. So this is just an example of that. This is a kind of a sensorial envelope in which you're looking at the left-hand side are human senses from vision, taste, olfactory, everything from balance and equilibrium to artificial senses. These are analogous to the human body, but so if you're thinking about the human vision from like 350 to 720 microns, all the way down to infrared or ultraviolet, taste, and then there are a series of ones that actually are not what the human body has. So everything from sonar to detection of electrical fields, the detection of Earth's magnetic field, and then of course pharmaceuticals in terms of the central nervous system. So this sounds kind of far-fetched, right? Until you realize that there are people out here doing this now. So this is Kevin Warwick, who maybe self-proclaims, I don't know, as the first cyborg. And by that, meaning just a kind of connection, a link between something that's both a relationship of a computer or a robotic condition tied to that of the human body. And what you're looking at here is from a couple of years back where this is a hat that has sonar on it, so much like a bat in which it bounces waves out that then come back and allow him to detect distance of objects in a room. He then goes and has that connected through an implant. Well, first it's connected to a computer, a laptop or desktop in the office, and then that laptop is connected to an array that's then put into his arm that goes directly to his central nervous system. This allows the sensor that's here to then be fed back into his body and allow his body to then see or perceive that signal. So unlike the other examples where I said where it's tied to vision or sound, things that we already have. This is bypassing all of our natural sensory perceptions and going right to the central nervous system to produce another one. And what he found out was that by doing this, he is blindfolded. I think this was something that he had in his body for 3 months. And the first 15, 20 minutes it took for his body to understand and identify those signals. And then by the second week, his body was actually able to identify those signals and be able to make decisions based on those sonar signals in the room. So he could actually move through his lab. I mean, it was a slower pace, but he was actually able to move through his environment based on those signals. So it's a realization that the central nervous system is a much more plastic system than we tend to think. You may have seen those that study where they gave someone glasses that turned everything upside down. So basically they turn these things on, and for 2 weeks these people are getting giant headaches and they can't see anything and they hate getting up every day because the entire world is upside down. And then one morning, bam, the whole thing flips. And their mind and their eyes readjust to that and turn their world back to normal based on a realization of what's been going on or what's been planted in front of their eyes. They then take it off, and it takes 2 more weeks for them to go back. I mean, part of the great thing about reading some of his papers, some of his kind of scientific papers, are that he's not just about the technology, it's also about the ethical and moral kind of aspects of this. All the release forms he has to file, all the release stuff, the stuff between the hospitals, the stuff between the universities, all the stuff is just basically a question of, not just because can we do it, we should do it, but what are those implications that come about because of it. But as you start thinking about this, you realize that our definition of maybe what space is, a combination of energy, again, we talked about that pink line. When we think about geometry, we think about surfaces, we think about lines, right? So whether or not you're sketching in your notebook, or whether you go to Illustrator, or whether you go to AutoCAD, Maya, Rhino, what have you, you're generally abstracting your ideas through a surface condition. It's a line that gets abstracted to a surface that then has dimensions in space that then becomes solidified as a mass. We don't think about drawing in gradients, right? But that's how energy works. Energy can't be created and defined as a single line. It's basically a gradient condition, just like this light, like sound. And so it's a way of thinking of space not so much as a Euclidean line, point, line, surface, but instead as a gradient condition itself. And then at that point, trying to figure out how the human body perceives those boundaries, makes access and entries, and understands kind of an interior. So it's both a combination of the material energies that create the gradient boundaries, the sensorial envelope, meaning how the human detects those boundaries, and then architecture, of course, is the correlation between those two. I cut this down to like 35 slides as a way of saving myself, and somehow it's still going. So I just wanted to show a couple of quick projects to kind of get this going. Primarily, I'm showing these first two because there's also often a discussion when I talk about this stuff, somehow I've had a kind of bad experience with geometry or was like abused somehow. And that this is like somehow an attack on it, and that isn't the truth. I mean, that's not what I'm doing. But the idea is that the intention is that geometry shouldn't be the first thing we pull out of our bag, and that there actually are other materials that can play a role. It's not the fact that we're going to get rid of it altogether, or that we're somehow going to be living in these worlds of microclimates in the environments around us, but the idea that somehow we have to at least put that maybe more into the foreground of how we're thinking about space. And so this was a kind of very early project called Amplification, which was in the MAC show in Los Angeles. I'm showing this just basically to show that these were 6 identical forms that then had a bunch of energy systems running through them. Some of them were lighting, heating, there was a dyed water system, vegetation, and then a fan system. And these are kind of just early simulations to kind of simulate how those energies move through it, so that the geometry was identical, but each one of these had those same 5 energy systems being used, but they were being turned on and off at different times. So even though it looked identical in terms of mass and shape, their performance on the inside actually behaved differently depending on sunrise, sunset, temperature outside, solar orientation, So they all kind of turned on and turned off at different points. That project then kind of became this earlier project for the Cheltenham Museum addition. So it's an existing project that had a series of buildings right across, and they wanted to demo one of them and add an addition to it. And what they talked about it primarily was this idea of a bunch of interior projects, interior programs that were, again, when we think about program and we think about these things, we think about program boxes, we think about foam cutting, we think about making a bunch of boxes that then represent activities that then get aggregated together that then create a shape. So instead, we thought, well, other than the fact that you want some seating outside and a loading dock, can we actually start thinking about these programs not as more of a gradient between inside and out, and that they don't all need the same type of care for control. And it's just like those vitrines that you were looking at, we created this kind of open plan that connected street in the front to the street in the back, which gave you complete access across the site, and then created these three planes, floor plates, that then had a large lung on the inside, a kind of glass structure on the inside, so that all the kind of lower level of activity, whether it was the cafe or some of the seating or some of the office systems or some of the retail that we moved to the bottom level, that could all be activated through an energy system which was then collected through that void in the reflected ceiling and moved up into the building to then inform the other activities. So you still have gallery spaces and such that have the most control, but then as you move through it, you realize you can actually start tweaking what those spaces are. And our pitch to them at the end was to say that but if you start thinking of space in this manner, we can actually reduce the square footage of the building that you need and reduce the price tag on that, and maybe reinform that into exploring how we can actually think about energy in a new way. So the projects in the office range from these kind of large-scale competitions, the Museum of World War II, the Cheltenham, Asplund, Estonia, and these are projects that were really much more large-scale, building-scale projects. And then down here you see a bunch of projects that are much more at the scale of prototypes, like workable project-scale projects that I'll talk about kind of quickly, because at this point, it's kind of a realization that if we're going to really kind of push these ideas forward, that maybe it shouldn't lean so much on the crutch of that geometric approach for building a building that then has these energy systems, but instead could be something all in itself. So whether you're thinking about an outdoor kind of rug, so you think out, this is for a project for the, in California at, in San Jose. For a temporary installation. And when we think about these outdoor spaces, we think of grass and these kind of ground covers in the landscape around you. You wait for a nice day, it's the good day, you go out, you enjoy the sun, it's not raining out, and you get this ability to sit outside and enjoy the kind of climate you have around you. And then we have these throw rugs, which are basically when you have a hard surface or wood floors, you take these rugs, you throw them around, and they allow you to have a kind of comfort that you wouldn't have normally. Small kind of rugs you can unfurl and take around. And an extreme example of this is AstroTurf. So, well, you know where AstroTurf comes from? So, now it's kind of a ubiquitous form. It's in nearly all, in most sports, generally not a good thing when people talk about artificial turf because of injuries and such. But it came about in Houston, Texas for the Astrodome, the so-called eighth wonder of the world, that had a completely enclosed interior space with glass windows, glass roof above it. What happened was, though, the space was so large, Houston is so hot, that actually the heat from the inside was such a debacle in terms of conditioning that space, but it also wound up creating its own weather system on the inside of the building. So you got these super warm areas below, you had cooler areas, some of the seatings, and you started getting a convection cycle that actually started creating precipitation on the inside of the building. And so they wound up blackening out the roof of the building to prevent this, which then killed all the grass. So hence the Astrodome, the Astros, and AstroTurf. So we took this idea of running with this a little further, and this idea of an artificial vegetation and these throw rugs to create these outdoor spaces that used white noise and noise cancellation so that you're in a kind of busy city park that could actually prevent you from hearing that kind of road traffic and busy noise. We had these heating coils that were wrapped inside a polymer metallic plastic that we formed that gave off heat. And then, of course, there was spectrums of light below that that allowed you to then kind of have a therapeutic aspect to it. And you kind of pull these together and you start to get these throw rug outside that doesn't require an ideal condition for you to use it, but instead starts to kind of augment and change that environment around it. So what I'm going to kind of close with here is just the idea of what the shape of architecture then becomes when you're not thinking about geometry, when you're not thinking about surfaces. So again, with the idea of that street light. If you think of a street light outside, that doesn't have an ideal form. And what I mean by that is that when there is a full moon, you have a lot of more light in your vicinity, right? And so you don't see the edge of that street light the same way you do, say, at a new moon when it's at its smallest. So depending on the environment around you and how that environment changes, that light, even though it's still the same amount of light coming out, same amount of wattages and so on and so forth, it's actually being perceived different by the eye because of the fact that the environment is pushing on it. So the environment, when it pushes on concrete and steel, it may weather it, but the idea is it holds steady, it still holds fast. If you think about a campfire, that same campfire, the same amount of fuel, and how that burns on a spring day versus a winter day is completely different, right? You have a different amount of fuel that has to go into it if you want to hold that boundary, or you let that boundary dissipate and it gets smaller and you burn your fuel faster. So if you think about this as a condition in which E being the energy and X being the force of the environment on it, that becomes then your boundary. This being pushed out, think of a fire, and then this being pushed on it, so whether or not it's a wind or whether or not it's cold. If that energy stays the same and that temperature on the outside increases, that space will get smaller. So what you have at your disposal then is to say, if I want that boundary to be held strong, what I need to do then is counter that with more energy from the variable that's pushing on it. So if it's a colder day, you have to add more heat. If it's a wind velocity, you have to turn and push against that air. To do that, though, you're going to actually change other qualities of the energy, right? So we all know that if you're sitting outside and it gets very cold very quickly around a campfire, and you throw 4 more logs on, not only does that fire get bigger, but it gets brighter, and it actually has probably a different color to it. So these things, when energy is used and expelled, it actually changes the aesthetic quality of that space in order to hold that edge, unless you choose to let that edge disappear, which, like street lighting, one of the beauties of that is that when you don't need it, you turn it off, right? So I am going to just jump to the last project. And these are just some photographs that I've done recently. These were just recently in Istanbul at the Istanbul Design Biennale. They're large format prints from, not a large format camera, but pretty close, of trying to figure out and give some visualization as to what some of these ideas and what these spaces would look like. And where they're being done now is through these physical models that can be rather large. So this one's probably 5 feet by 6 feet. You know, this is probably 15 feet by 5. And the idea is to actually build these as physical systems and then photograph them just for one photograph, tweak them in terms of trying to add some of the elements that are required visually for you to understand, for us to all kind of engage. And then pull forward now and start actually prototyping and testing these as workable approaches for a research project. So in an odd way, what I'm doing going forward now is actually working both in one arm in art and one arm in engineering. Obviously, architecture is the end game plan here, but it's requiring a kind of slightly different approach. And when we think about that shape I showed you, what we're looking at here is a kind of artificial sun condition that is being held up by a kind of a drone. You probably think of drones again through military, but they're also a very huge aspect of agriculture now, being able to actually monitor and control and spray in a very kind of controlled mechanism. So it's a kind of moving system that then works with a power supply, ability to vaporize water, lighting both in terms of the main source and then the secondary source, and then working with thermal conditions and electromagnetics so that you get a space that this being the shape of architecture, meaning that is the boundary that's produced when on-site humidity or solar or rain or temperature or air velocity come in contact with then the project itself. And this is essentially an Odom diagram, which is usually used for diagramming ecosystems. Of course, in this case, the ecosystem is the size of an architectural pavilion, and that becomes then the shape. And so these then are the photographs in which testing both the shape of the mechanism that could potentially produce this, and then the human bodies and how they engage with it. So somebody who has access either through a wearable technology or through an implant that allows them to engage a frequency of energy, whether it's electromagnetic or so forth, in a space, and then a secondary person who doesn't have that access and therefore can't cross that threshold. The idea with this is that, again, like street lighting, is that you don't have to, when we think about architecture, you hear these, so many statistics, you can't know what's real and what's not. But one of the big ones you keep hearing about is the fact that by 2050, half the world's population will live in an urban system, right, an urban setting. Of course, what's urban? Houston or New York? But, so there's a lot of definition of what urban is, but one thing is for sure, though, is as density of urban spaces increase, our public spaces, the public parks, the plazas, become more and more important, right, as places in which we can engage. And as Central Park is sort of known, Central Park, the kind of big law on Central Park is that no new buildings should be built inside Central Park. That hasn't been the case. There have been a lot of encroachments. But our kind of public realm, our public space, our parks become an extremely important aspect. And the idea is, how do we have access to those, and how can we use those more and more when population increase does occur and there's more demand for them, but at the same time not build solid structures within it. So if you think about, much like street lighting, these become kind of ground plane systems in which these can swap in and out and go back to a home base and then come back on and relocate. And when something goes dormant, it leaves and goes away. This is just another study looking at it in a winter month. So that shag carpet, I showed you the idea of kind of integrating a kind of carpet system within a zone itself, a kind of larger detail in which both the people sitting here and the person who then moves through the space would actually change the space itself. So as 3 people occupy it versus when a 4th occupies it, actually changing the shape of that. And then finally, a kind of winter condition in which these become, again, a little bit like the lighting example, in which this becomes an individual space that maybe then allows you to have to hop out and then back into a second one. But as you see it in the distance, you start to realize these things can actually come together, populate in a kind of more dense zone that then allows you to actually create much larger spaces of occupation and use. And so that space in a winter month that has a much more tight, controlled shape, because the pressure is greater, would then look somewhat differently in a different month because of less of those pressures. In a weird way, what you start to get is a vernacular, meaning you could buy a home online and get the plans and get the paint specs and get all the construction specs, and you can build it in Mexico City or in Waterloo, and you're more or less going to get the same shape and the same aesthetic. It won't perform the same, it won't deal the same with the climate, but you'll have a shape that's identical in those 2 places. When you start thinking about an architecture that is shaped by an energy system and then the exterior forces that work upon it, you start to get something that this would work very different in Houston, Texas than it would in Toronto, right? And it would work very differently over a course of the month, the year, or decades in which the kind of climate around you is changing. And so just to kind of conclude, when we start thinking about this, when we think about riding the lightning, this is tongue-in-cheek, of course, is that it will provide what this can do is it provide a flexible and increased public spaces. So like I was just mentioning, in the sense that one of the benefits when you start thinking about this, and we think of, again, is this idea of something that can be turned on and off, is that it can provide resources, it can provide access, but at the same time, when it's not needed, it can just go away. Entropy is a strong force. It can just dissipate away and then come back when needed. So it's not something that has to be used all the time or thought of as a constant condition that exists through eternity. Things decay as soon as they're built. The question is here, can we actually work with that? Second is that it's tunable and updatable. So just like that last project I showed you, there's clearly geometry, there's clearly form in it, and there's clearly geometry and form in some of the larger scale projects. But a lot of it also deals with the mechanisms and the software and then the energy and the efficiency of that and deployment of it that can be upgraded and changed. So Tesla, for instance, everyone has heard of. What's really great at some of the stuff they're doing now is not only do you have the car itself, but a lot of the updates that you're getting now are software updates. So it's ways in which the car is communicating with the subcomponents. I mean, clearly some components need to be changed from time to time, but the upgrades are really about how parts of that car are communicating with each other, and how it's performing and how it's gauging those performances and changing those performances. So something like this is the sense that when a project like this is created and formed, is that this can actually continue to evolve and change over time as batteries get smaller, as we have a better understanding of the site itself, as we have new ways of kind of changing those mechanisms. Third is that the intention is to engage the public on energy and the environment in the sense that I do see these as kind of pavilions in many ways. That architecture has a strong and long history of pavilions that start off as early stages of kind of bigger ideas that need to be tested and run. And so by doing this, the idea is to get these out there, start giving shape, giving it essentially in a weird way, and I'm not trying to make this a capitalistic discussion, but to make it a commodity, to make it something that people want. Because when people want something or people see something and they demand it and they want to see more of it, they start to pressure people. And they pressure the right people, hopefully, the politicians, the things in which codes and some of the policies that go into where funding is going could change, because there are many, many smart, talented people who are working on this already. And again, this question of the umbrella of the architect. The architects, we're not specialists. We're not going to invent the new battery. We're not going to create a more efficient battery, most likely. Maybe some of you will. But the question is, that's going to come from somebody else. But if we can give the kind of the pressure of a general public to both be educated about the environment, because believe it or not, in the United States, with the Republicans taking over, we're still having conversations about whether or not climate change is real. And this is, I think, a way in which we can have a conversation which really isn't about maybe always a discussion of conversation and holding on to now, but realizing that we can plan together about what the future could be. And third, it's really, in many ways, also about prototyping social implications, some of the legal, ethical, and moral aspects when we talk about the human body. And so using these as a way of actually having these discussions and having these as a test bed of talking about many of these things and how they play themselves out. I didn't talk about it too much, but when we were looking at the idea of these materials and how they change, Robin Evans talks about the developed surface or doors, passages, the idea of the advent of the corridor. When these things happen, we don't always know what the kind of repercussion will be. As an architect, you can't stand back and know what this work and the kind of pressures that are on you and the work that you're producing and knowing what those things are going to trickle down and produce. Instead, all you can really do is kind of keep an open eye, knowing that what you're doing and when you're tinkering with these things will have implications, and knowing that they are going to have some ramifications that are unintended. And so being able to talk about both the discussion of energy and the relationship of the human body and how it is potentially it's not going to be a universal thing. This isn't going to, not everyone has the same phone service, right? Not everyone has the same internet connection. Not everyone has the same, even in a development in which we all have personally access to making those choices, we don't have that, right? So there's certainly going to be a large discrepancy between this. But the question is, we should be at least having these conversations. So thank you.